Welcome to the satellite communication course. So we see here the what are the various GPS errors. There are the GPS errors that is about the ephemeris error. That is ephemeris error regarding that position of the satellite. If it is changes, there will be ephemeris error. A satellite clock error because that satellite uses a automatic clock. If there is a variation in the automatic clock, then there will be error. Then ionosphere error because we have that ionosphere layer is there. We can say that there will be ionosphere layer or ionospheric error is there. Why this error occur? Because that ionosphere has a diffractive medium. Why did diffractive medium? Because of the free electrons is present in that ionospheric layer, and that region of that ionospheric layer changes in the day and night because that sun rays will activate that free electrons, and because of that medium will be dense or poor there. So according to that, when signal propagating through this, so they will be diffracted. It means we can say that refraction of that particular signal is there, but there may be a small variation that angle. Okay. Then another error is about a troposphere error. In a tropospheric region, there are the variation in the temperature, variation in the pressure, variation in the humidity, and because of that particular variation, so that will change the velocity of the wave propagating through that particular tropospheric layer, and because of that, there will be a propagation delay, and that propagation delay occur at the transmitting side or at the receiving side. So that's why that error is called as a troposphere error. Or we can say that a tropospheric delay. And that tropospheric delay because we know that a receiver position and the satellite position. Because of that delay, the tropospheric delay, if there is a lower elevation angle, then that tropospheric delay will be a more. And in that case, for the specific elevation angle, that error will be different. So we'll see that what will be the error for that particular tropospheric. So because here in tropospheric error, that reason for this particular error is because there is a variation in the signal path, and because of that variation in the signal received at a given particular elevation angle. Okay, so that's why there will be a troposphere. Then another is about a multipath error because that multipath error means what signal received by the GPS receiver from the many location. Why many location? Because at a region where that receiver is present, there are a lot of obstacles present, and because of that lot of obstacles, signal will be reached to the receiver from the many obstacles there, and because of that ob- signal received, so that signal received, suppose I am saying that this is about a satellite, it transmits the signal, and here we have the receiver now. So there are the building, there is lot of buildings are there, there may be a tree likewise. Whenever the signal will reach here, so they have the different paths. Okay, because signal will be reflected from the building, reflected from the tree, or direct signal. Okay, so multiple signal reach to the receiver means multipath signals are coming. So that is called as a, that multipath signal is nothing but a multipath error, and that multipath error because of that reflected signal from the different obstacles that will be entered to the receiver, and that error or that particular effect is more significant if you have a receiver that will be present on the a ground there, and nearby the ground there are the large obstacles present. Okay, more number of obstacles present. So in that case, there may be a multipath error. So to avoid that, this particular multipath error, So we can use a antenna. That antenna will be of a ring-like structure, okay, and that ring-like structure antenna will eliminate that particular signal with a low elevation. So we need to select a proper antenna for removing that multipath error there. So that are about the error. So now another error is about, we can say, that is about a receiver noise, because we can consider that a signal received at the particular receiver, we say that received signal came from the multiple path, that may be a direct path or a different path or likewise. So that's why we can say that there may be a variation in the phase or variation in the amplitude, and because of that variation in the phase or variation in the amplitude, then signal degrades, and that's why there will be the error. So that is nothing but that a multipath error. And then receiver has some noise because of a component and all, or that signal component. Okay, so likewise, so we have the lot of error that is related to the that signal received from which direction there, as per the geometry of the receiver. So what is the position of that particular receiver, whether it is vertical, horizontal, or what will be the position of that particular receiver. So according to that, there will be a noise, and that noise is called as a satellite noise, or you can say that a receiver noise. So there are the various errors and various noise present. So we'll talk about that. What are the various errors? We'll have the error sources, and that error sources we can write in terms of the what will be the difference here. So we can say that range error. So supposed to be, if there is a ephemeris error, then there will be error of 2 to 3 meter. We have satellite clock error, that is about 1 to 2 here. Then ionosphere, all are in meter, okay, 7 meter here. Then troposphere, that is about zero point 0.6 meter. Then we have a multipath there, 1 to 2 meter here. That is in the terms of a range here. And then we have a receiver noise, because of that receiver noise, that is about the 1 to 2 meter. So that is about the receiver noise because of that position of the satellite. Sorry, position of that receiver toward the a satellite. Means satellite observation geometry at the receiver. So that's why there will be error. So range, there may be variation in the range. So that's why that is called as a range error. So then we'll talk about that two more tables we have. Maybe it will not be visible to you right now. So I'll share those table to you, okay, later on. So that is about a table that will explain you about that what are the various carriers. Here is about, I'll just read out. Here is one satellite. It has a L1 carrier. That signal is about received by a code. EIRP of the satellite. What will the path loss? What will be the atmospheric and ionospheric loss? Then receiving antenna gain, received power level. So likewise, that is about a signal power received by the receiving signal. So now again that which antenna we are using, that is at a receiving side, so what will be the polarization of that antenna? Whether it is a right hand circular polarization or a left hand circular polarization. So according to that, that noise will be different. Okay. the position of that antenna, and then what will be the polarization used for receiving the signal there. So that is about, we say, a, a satellite, that is about a GPS errors and all. So next about differential, next topic, differential GPS. Now as I told you earlier, so we have the a receiver, GPS receiver, that receives the signal, and according to that particular data, it will find out the position, or it will find out the location there. But because there are the errors in the satellite position because of that ephemeris data, or there may be error in the onboard clock, or there may be the error caused by the propagation media, that is troposphere error, or we can say that ionosphere error. So then because of those error, then receiver contains a error there, and that error can be minimized, or that errors can be totally eliminated by using the differential GPS system. So in the differential GPS system, if you see that it has some particular reference station is to be installed. So suppose I am saying here reference station that is to be used. That reference station transmit the signal. Here is your antenna now transmitting station, and here there are the multiple satellite because that signals are received from the multiple satellite. Okay, just I just draw the diagram first. Okay, now these are about the four satellite because we say that there are the four star satellite. Here is about a reference station, and this one we can say that is about a user GPS. Now that reference station and the receiver, we can say that signals are received from the various satellite. Okay, so that is about the signal received here. Okay, these are the signal received from the satellite. So similarly, we have the reference station. There is some specific antenna we supposed to say that. Okay, likewise, we have the antenna now. So it is again receiving the signal from the various satellites. Okay, likewise. We can say that these are receiving the signal from the various satellites. So as I told you earlier, to remove the error or to eliminate the error, so we can introduce the differential GPS system. We can say that DGPS. Okay, differential GPS system or a DGPS. So it has some reference station installed somewhere at some particular location and then that reference station will receive the clear signal from the receiver. Means that location is to be identified, means at high hill there is no any obstacles. Okay, nearby any obstacle. Okay, so that is about one particular specific location. That signal received at this particular location has a less obstacle, no multipath. Okay, likewise. So means that location is obtained such a way that there are no obstacles nearby. So that's why you can say that that reference station is installed at a strategic location so that it will receive a clear signal from a satellite. Now then, so that is about, we can say that a receiver signal, no obstacle, because of the no obstacle, the accuracy of that signal received is high here. Okay, so we obtain that particular location. And then we supposed to be consider that a receiver is placed at some particular station there. That is about a user GPS receiver. And here that reference station, that that reference station is nothing but a GPS receiver here. Okay, this is about a GPS receiver. This one is about a GPS receiver. But this one is the user GPS receiver. And this one is about a GPS receiver that is for the reference station. It measures the transit time delays, as well as it will measure that whatever the satellite signal sent, that is about a GPS data, and again it will calculate the position there. Okay, so means what happened here, that signal received from the satellite, it that reference GPS station will measure the it transit time delays, and that transit time delays that will be measured from what data is to be sent by the satellite. Again it will obtain or it will calculate the position of the satellite. Now here, if supposed to be that calculated data is supposed to be, it has some particular error. Suppose we say that there may be a error in the position, or there may be a error in the range there. Then according to that, that particular reference station repeat again the same process, and then again it will calculate that each and every information of for the given satellite. Means that is about the range as well as the position, and that information is present in that particular reference station. And that information again supposed to be, if suppose at that time supposed to be there may be error there, and that error is present there, then again it will be calculating the information again, that satellite send the signal, and again it will be received, and again it will obtain the what will be the range and all. So now at the receiver, suppose, okay, now that range and position calculation is done at the receiver side, that reference station side. Now at the GPS receiver, supposed to be there may be any error occur at this particular receiver, then user receiver can correct that range by using the correction data from the reference station. Now this is about the user GPS receiver, and this one is about a reference data here. So that from the reference station to the GPS station, there may be a terrestrial link. There may be a terrestrial link. We can suppose to be consider that there may be a terrestrial link in between that reference station, and we can say that in between that a GPS system. Means if supposed to be any error occur at this user receiver, then this GPS receiver can correct that particular range by using that correction data from the reference station. If supposed to be there is a another error, supposed to be, we can say that there may be a atmospheric error support, atmospheric error. Okay, and that atmospheric error we supposed to say that earlier, that atmospheric error is about what, maybe about a 2 meter, 2 kilometer, or some particular range, or there may be a error, ephemeris data, there may be a clock error. That all the errors, if supposed to be received by this particular receiver, then that errors will be removed by using this particular reference station. Even if supposed to be that GPS receiver receives the multipath signal, and according to that there may be a error, or there may be a receiver noise at the GPS receiver. That receiver, whichever the error are there, that can be corrected. But some error that is about a multipath signal received by this receiver and the receiver noise at this receiver, that cannot be corrected. Only the ephemeris data, only the clock errors, only the range, that can be corrected by taking the reference station. So here we have the reference station and a GPS receiver signal. Both are receiving the signal from the same satellite, and because the position of that receiver and that reference station in such a way that they are getting this information from the same satellite. But again, if you consider that the reference stations have additional information regarding that whatever the error in that range of the satellite there, and that information that will be shared to this GPS receiver, and that GPS receiver is present within a few hundred kilometers of a radius of this reference station, and that GPS receiver at that particular location remove that particular error in that particular range, and then according to that they will share the information to the users there. And that is about, we say, is a, we can say that a GPS receiver, that is about a differential GPS receiver. Now nowadays if you see that we are using that a assisted GPS, so means we can have we that signal received the information, that a receiver, GPS receiver receive the information, and then that will be provide the information regarding that a tracking or all other additional information they are providing. So that is about, we can say that another way, another GPS system is called as the assisted GPS system, and that is about this. That's all we have seen that a differential GPS system and a GPS system there. So there are the various navigational systems available. That other navigational system. So now this is about US GPS system that we have learned, and we say that it has a 24 satellites that are in use, but total 31 satellites are there. Another system is about, we can say, a Galileo system, that is the European system. Then another navigation system is about a GLONASS, that is about a global navigation system, that is for the Russia. Then IRNS, that is about the Indian regional navigation satellite system. Then we have the Chinese satellite navigation system, that is a BeiDou. And then we can say that a MTSAT, that is a satellite system, or MSAS, that is satellite system used by the Japan there. So there are the various navigation systems used by the various countries, and if you consider that a Indian navigational system, they are using a L5 signal, and they are sending the satellite, that satellite sending the information on these two carrier, that is about 1561 megahertz and 1207 megahertz, and that everything is same that we have learned for this US navigational systems and all. Okay, so that is about ISRO developed their own navigational system, and that navigational system, if you consider, it has a space segment with a 7 satellite, with 3 satellites in a geostationary orbit and 4 in inclined geostationary orbit. That is about the Indian navigational system. Only 7 satellites are there. So now if you consider that, what are the various applications of the GPS and all, so because a GPS receiving the information from the satellite, So we'll get that information. According to that, we can find out that a position, and we can find out the time, because or we can use that information for the tracking devices and all. So nowadays, if you consider that a lot of components, they have the GPS receiver or a GPS tracker that are used nowadays for the tracking system. So mostly, if you see that the ships and aircraft, they are using that GPS navigation system from old days. Nowadays, most of the devices nowadays, vehicles and all, they have the GPS system included there. And with this, we can say that we have seen a satellite navigation system, and in that satellite navigation system, we say that a satellite navigation system that will be used to provide the accurate positional information to ships, aircraft, and mobile users on a ground. Generally, we say that the three satellites are used to provide the information regarding the position of the receiver, but fourth satellite is needed to eliminate need for an accurate clock source in the receiver. Then a satellite navigation system, it has a three elements or three components. One is about a space segment, ground segment, and a user segment. Then a space segment is nothing but a constellation of a satellite in a medium Earth orbit, so that at any time four or more satellites are visible to the receiver on the Earth. Maximum 12 satellites are is visible. 11 to 12 satellites are visible at the receiver side, but only three or more satellites to be used for the uh, information. That information regarding the position and time. Okay. If you consider that a geo orbit, then we require only two or three satellites for the GPS that is in a geo orbit. Then a ground segment, we say that it consists of a master control station, monitoring station, and uploading station. Then monitoring station collects the ephemeris data, clock error, and the data for the satellite, and then send it to the master control station. Then the control station provides that that information, process the information that received from this master control station, process the data, and prepare that navigation message and send to the uploading station, that is a antenna station. So generally that GPS transmits that navigation data in a two format, and that is about a course data, C by A data, course data for general public, and a precise data for the military application. Then we say that a differential GPS system that is developed, that is used to eliminate the inaccuracy in the received data from the satellite. That's why it improves the position accuracy. There are the various error sources, and that error sources include the errors in the satellite ephemeris, satellite clock errors, and then errors caused by the propagation delay variation in the ionosphere, troposphere, receiver clock errors, and a receiver noise. These are all about the navigation satellite navigation system. With this, we'll end the satellite navigation system. Thank you.